I didn't see you there. Welcome to Dr. Sade Presents Fun with Chemistry. Now class, today we're going to be going over the can crushing lab. You can find material about this in sections 5.1 and 5.2 of your book, Chemistry. Now class, let's begin.
First we're going to talk about pressure. A gas exerts pressure onto its container when the gas particles of the gas hit the walls of the container. Atmospheric pressure is when the gases of the atmosphere exert pressure on a surface, like this barometer, mercury.
760 millimeters of mercury is equal to 1 atmosphere at standard temperature and pressure.
Another name for a millimeter mercury is called a torr. The SI unit for pressure is a Pascal, or force over area. 101,325 pascals equals 1 atmosphere.
That is pressure. There are 3 gas laws to describe the relationship between pressure, temperature, and volume. First of these laws is Boyle's law. Boyle's law was described by Robert Boyle as PV equals K, where K is a constant that is given at a given sample of air at a specific temperature. Now, Boyle's law can be interpreted as also P1 V1 equals P2 V2, which describes how if you change either pressure or volume, then the other will change as well. This relationship is known as Boyle's law. The next one of these laws is Charles' law.
Charles' law explains the relationship between volume and temperature by using the equation V equals BT. It can also be written as V1 over T1 equals V2 over T2. Charles' law also explains the relationship between volume and temperature. It is a direct relationship, meaning if volume increases, temperature has to increase at the same rate.
Third of these laws.
In Charles' law, pressure remains constant.
Next of these laws is Avogadro's law. In Avogadro's law, the equation V equals AN is true. This equation states that for a gas at a constant temperature and pressure, the volume is directly proportional to the number of moles in the gas. These 3 laws describe ideal gases, but if you combine them, you get the ideal gas law of PV equals nRT.
Now we're going to show you how to crush a can using science.
Michael, stop drinking all the lab equipment. Come on now. Hey guys, this is the can crushing lab using boiling water in about 10 milliliters of boiling water in a can, an ice bath, and we are going to flip the cans into the ice bath, and you will see a very nice crush.
Let's see what happens.
Ready?
Yeah.
Set.
Go, you gotta flip it quickly.
Ready?
Oh, Jesus. Yeah.
Oh, that was...
Oh!
Oh my goodness.
Do it. So as you can see, when the can is placed in the water, it does not crush immediately. The temperature has to change throughout the can before the full crush can happen. The can crushes because the air is trying to escape and create an equilibrium pressure, but the air is trapped. The outside high pressure pushes in on the inside low pressure and crushes the can in an attempt to create equilibrium. At the end of this clip, the water escapes due to both a vacuum and also the fact that the water vapor inside the can changes quickly to water through condensation. That's pretty cool. How does that happen, Sammy?
Well, in the ideal gas law, what happens is that the volume and these two, and the moles and the R remain constant.
Ah, that's actually kind of cool. So I think I get it. So when you have the can and you have a hot plate under it, the can is very hot on the inside. And when you have an increase in temperature, pressure must rise too. But when you suddenly flip the can and put it in the ice bath, temperature drops very suddenly. So then pressure drops too. That low pressure system there's a big difference between the outside pressure and causes the can to crush and implode on itself. That low pressure system also acts like a vacuum and sucks water up back into the can when you flip it over into the cold water bath. Am I right, Sammy?
Yeah.
Good job.
So, to re-summarize, the ideal gas law describes the relationship between the three gas laws by Boyles, Charles, and Avogadro. These show that during a can crush experiment, the can will crush due to the can trying to create an equilibrium pressure inside and outside of the can, and a vacuum effect will take place, sucking water in, which then drains out when you lift the can up at the end of the experiment. Yeah.
Ah, how do people get to my house so much? Well, that concludes our lesson today. I hope you enjoyed it, and have a good night.